Introducing our group's member. We have one Nur Fadila Amalin binti Wan Muhammad Sayuti, Nur Ain binti Zuri, and Siti Nur Khadijah Afifah binti Rizwan.
Application of differentiation related rate. In this video, we are going to talk about application of differentiation, which is related rate. What is related rate? Related rate is two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, we can find out how fast the other is changing. This generally involves writing an equation that relates the two variables and deriving the equation with respect to time. Chain rules become important for the correct resolution of this problem. Implicit differentiation is often used. Why we use related rates? Related rates are used to solve problems involving quantities that change over time and are related to each other. They are especially useful in situations where direct measurement of a rate of change is difficult or impossible, but the relationship between different changing quantities can be established. Related rates provide a powerful mathematical tool to understand and analyze dynamic systems in various fields by linking the rates of changing of interconnected quantities.
Problem 1. Problem statement. The diagram shows a cylindrical container of diameters 1.2 meters and height of 2.5 meters. Water is poured into the container at a constant rate of 0.5 meters squared per second. Calculate the rate of change of the height of the water level at the instant when the height of the water level is 1.2 meters. Problem solution. Step 1. Formula of volume of cylinder, which is volume equal to pi r square h. The second step is identifying. Water is poured into the container at the constant rate of 0.5 meters squared per second, which is, we can summarize it as dV over dt equal to 0.5 m square per second. Second, calculate the rate of change of the height of the water level at the instant when the height of the water level is 1.2 meters, which is, we have to find dH over dt when the height given is 1.2 meters. Step 3 is differentiate the formula, which is, the formula is volume equal to pi r square h. Then we have to substitute the value of radius, which is 0.6. Then the volume is 0.36 pi h. Differentiation of the volume gives us dV over dH equal to 0.36 pi. Last step is solve the problem by chain rule. We have to find dH over dt, which is equal to dH over dV multiplied by dV over dt. So the value of the dH over dV is 1 over 0.36 pi multiplied by dV over dt as 0.5. We substitute the value of the pi, which is 3.142. Then we solve the calculation, and the answer is 0.4420 meter per second.
Problem 2. The diagram below shows a metal tube with side at centimeter. The tube will expand when it heated. At length of 4 cm, the volume changes at the rate of 0.52 cm3 as -1. Find the rate of change of the length x when x equal to 4 cm. For our problem solution, first thing first, we need to know the formula for volume of cube. The formula of volume of cube is V equal to x cube. After knowing the formula of volume of cube, we need to identify from the question. From the question, it said, at the length of 4 cm, the volume changes at rate of 0.52 cm3 as -1. So, we can declare that dV over dt is equal to 0.52 cm3 as -1. Next, the question asks us to find the rate of change of the length s when s equal to 4 cm. So we can declare that ds over dt with s equal to 4 cm. Third, we need to differentiate the formula of the volume. Our volume formulas for cube is V equal to x cube. When we differentiate the volumes formula, we get dV over dx equal to 3x squared. So, after we differentiate the formula, we can substitute the value of x, which is equal to 4, into the equations. 3 bracket of 4 power of 2, we will get 48. After we get the value, after we differentiate the formula, lastly, we can solve the problem by using the chain rule, which is dx over dt equal to dv over dt times dx over dv. So our value of dv over dt is equal to 0.52, and before we already find the value of dv over dx, but our formula is dx over dv, so we need to change into 1 over 48. So 0.52 times 1 over 48, we will get the answer, which is our final answer is 0.0108 centimeter as -1.
In conclusion, related rates problem in calculus provide a methodical approach to understanding how the rates of change of different variables are interconnected. By following the steps to solve it systematically, you can effectively solve related rates problems and gain insight into how different quantities change relative to each other in various real-world scenarios. These skills are valuable not only in calculus but also in fields such as physics, engineering, economics, and biology, where understanding dynamic relationship between variables is crucial.